To answer it, yeah. Yeah, so good morning everyone. So welcome to yet another online tutorial on principles of communication system. So in previous session, that is yesterday's live session, we discussed about the time domain description of single sideband modulated signal, right? So that is what we can see here, right? The time domain description of single sideband modulated signal, right? A single sideband modulated signal with only LSB retained, it is the expression, it is AC by 2 m of t cos 2 pi fct plus AC by 2 m cap of t sin 2 pi fct, right? So if only LSB is retained, it is plus here, right? Instead of that, if only USB is retained, it will be minus here. So please do keep that in mind. So while solving problem, right? And this m of t is our message signal, AC cos 2 pi fct is our carrier signal, right? And what is this m cap of t? This m cap of t, it is nothing but what? Hilbert transform of m of t, right? M cap of t is Hilbert transform of m of t, right? If if m of t, I'll in day before yesterday's video, I've given some examples. If m of t is cos 2 pi fct, right, m cap of t will be m of t is cos 2 pi fct, m cap of t will be. So what actually is Hilbert transform, right? One easiest way to what interpret or find out Hilbert transformers, right? In Hilbert transform shifts the phase of all positive frequency component by an angle minus pi by 2. So this m cap of t here straight away I can find. So we have different methods to what evaluate Hilbert transform that you will study in detail in 6M. So, but for instance, some results which are required for us, right? If m of t is cos 2 pi fct, m cap of t will be cos 2 pi fct minus pi by 2, right? Cos 2 pi fct minus pi by 2. So this will be, what will be this? It will be sine 2 pi fct, right? So cos 2 pi fct minus pi by 2, right? It will be plus sine 2 pi fct. So if you ask me how to know if it is plus or sine, right? So there may be different ways to what like interpret that. How I remember is, right, whatever, if cos, it is cos theta plus or minus pi by 2 or theta plus pi or whatever, right? If which is getting added as pi by 2, if which is getting added as pi by 2, cos will become sine and sine will become cos, right? And right, so here we have theta. We'll assume theta to be some angle which lies in first quadrant, right? Theta is some angle. So this is first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant, right? So normally we'll start measuring angle with respect to actually what positive x-axis or positive real axis or whatever, right? So from positive x-axis to this, so theta, if we assume it is in first quadrant, theta minus pi by 2, it has to lie in actually what? The fourth quadrant. Theta minus pi by 2, this theta, from that I should travel a pi by 2 radian in clockwise sense. So theta minus pi by 2 will lie in fourth quadrant, right? So in fourth quadrant, cosine is positive, right? So if you might be remembering this, all students took coffee or all silver teacups or whatever. So in first quadrant, all the trigonometric functions are positive. In second quadrant, only sine is positive, and third quadrant only tan is positive. Fourth quadrant, cosine is positive. So in fourth quadrant, cosine is positive. So cos 2 pi fct minus pi by 2, it has to be positive, and as it is actually what pi by 2, it has to be sine. So it is plus sine 2 pi fct. That is right. So students used to ask me, that's why I just wrote, right? So what you want to know is Hilbert transform of m of t will be, Hilbert transform of cos 2 pi fct will be sine 2 pi fct, and Hilbert transform of sine 2 pi fct will be minus cos 2 pi fct. So you can find that. But for instance, we need only this much, right? So now we'll move ahead and I'll just move ahead and read out today's problem. Right. Today's problem, right? please read down. I'll read out the problem. Right. Consider the message signal M of t. Right. The message signal M of t containing the frequency components 100, 200, and 400 hertz. Am I clear? Whether you can follow what I'm reading out? Right. So consider the message signal M of t containing the frequency components 100 hertz, 200 hertz, and 400 hertz. Right, 400 hertz. Now this message signal is applied to an SSB modulator together with a carrier at 100 kilohertz. So this message signal, it has 100 hertz, 200 hertz, and 400 hertz. This is applied to an SSB modulator together with a carrier at 100 kilohertz. Right, together with a carrier at 100 kilohertz. This message is applied to a SSB modulator together with the carrier at 100 kilohertz with all USB retained with all. The receiver uses a local oscillator that gives a cosinusoid of frequency 100.02 kilohertz. The coherent detector employed at the receiver uses a local oscillator that gives us cosinusoid of frequency 100.2 kilohertz. Right. Determine the frequency component of the coherent detector output. Right. Determine the frequency components of coherent detector output. Right. So that is the first part, and second part, which will be your assignment. Right. Second part, which will be your assignment. Right. Repeat the same for a single sideband modulated signal with only LSB retained. Right. So this is the question. So given a message signal, it's not a single tone signal. It has actually what? 3 different frequencies. It will be cos 2 pi f1t, cos 2 pi f2t, cos 2 pi f3t. So 3 different message frequencies are there, and carrier frequency is 100 kilohertz. Sorry, I forgot to tell. Carrier frequency is 100 kilohertz with only upper sideband retained. Right. And we are using a coherent detector to detect it. Right. We are using a coherent detector to detect it. But actually, we have studied, if you are using a coherent detector, right, the frequency and phase should be exactly same as that of carrier frequency. But because of some reason, the coherent detector's frequency is not same. It has actually a small frequency error or frequency offset of 0.2 kilohertz. Right. These things are given. Right. Now you have to find what are the frequency components of coherent detector output. Right. So what I'll do is, should I read out the question again?
Yes, sir.
Yes, sir.
Whether the question is clear?
Sir, your voice is breaking.
Voice is breaking. Now is it proper?
Yes, sir.
Now, okay, right. So I'm really sorry. Normally I used to sit in my cabin and do, but now some other work is happening there, so I'm not able to sit. So I relocated to a new place. Right, difficult to actually write on my writing pad in this position. I'll just change it slightly. By that time, you please read the question. right? I'll be back in exactly 1 minute, right? I'll make some arrangement for me to keep my writing tablet, right? So please, open, please read out the question, right? Yeah, I now am I audible? Is it? Am I audible?
Yes, sir. Yes, sir.
Yes. Okay. Okay. Fine. Voice is breaking. No, right?
No, sir.
Okay. Okay. Fine. So now what we'll do is we'll just note down what is given in question. Right. So me also please note down what is given is we maybe I'll draw the system model first. Right. I'll draw a system model first. So how we'll get an SSB signal? SSB signal we'll get, right. First we should get an, right, DSB. So for that I should give a carrier. The carrier is actually what? Cos. Sorry. Right, cos 2 pi FCT. So here FC is given to be what? 100K, 100 kilohertz. So it will be cos. It will be so like maybe I'll write it like this only, maybe later on. So it is understood FC is 100 kilohertz, right? So we should give an M of t, right? M of t and carrier if we give to a product modulator, and then if we pass it through a filter, right? So as I need to retain only upper side band, I should pass it through a filter HU of actually what? T. It will retain only upper side band. So what we'll be getting here, that will be actually what? S USB of T, right? So we'll be getting S USB of T, right? And further, if I give this S USB of T to a coherent detector, what actually is a coherent detector? A coherent detector is nothing but what? It will have a product module here, right, with some local oscillator producing some frequency. This local oscillator is producing a frequency, you can write here, cos 2 pi, right? Okay, it is supposed to produce a frequency cos 2 pi FCT, but unfortunately it is producing cos 2 pi FC plus some delta F T, right? So this FC plus delta F was given as actually what? 100.2, kilohertz, right? So SSB signal will be multiplied with cos 2 pi fct. Then it will be passed through a low pass filter, right? It will be passed through a low pass filter or a filter to get the detector output, right? To get the detector output, right? So this is the system which we are discussing about. So now we should know what is this m of t, right? What does this cos 2 pi fct? So carrier messages, I'll just note down this m of t is, it has three frequency components, namely 100 hertz, 200 hertz, and 400 hertz. So you don't have to get confused. If there are three frequency components, what you do is you consider three different sinusoids or cosinusoids with three different frequency components. So I'll consider cos 2 pi f1t plus cos 2 pi f2t plus cos 2 pi f3t, right? So f1 is 100 hertz, f2 is 200 hertz, f3 is 400 hertz. So this will be cos 2 pi into f1. So I'll write 2 pi times 100t plus cos 2 pi times 200t plus cos 2 pi times 400t. Are you able to take it down along with me?
Yes, sir.
Yes, okay, you should. You must be right. Then, what is carrier? What is carrier at transmitter? At transmitter side, carrier is cos 2 pi. Sorry, 2 pi times. What was carrier frequency? If anyone can unmute and tell. It was 100 kilohertz, right? So I'll write here as 100 kilo times t. This is carrier frequency, right? Now, what will be S USB of t? What will be S USB of t? Yesterday we found the expression for S USB of t. Anyone remember that? Right. What will be? Just at the beginning of the session, it was being displayed on this screen. Right. What will be SUSB of t? I told if it is LSB, that is plus, and USB if it is minus, and all those things I told. Right. I'll just show it once again. Right. Right. You can see if it is SLSB of t, it will be AC by 2 m of t cos 2 pi fct plus AC by 2 m cap of t sin 2 pi fct. And if it is only USB, it is AC by 2 m of t cos 2 pi fct minus AC by 2 m cap of t sin 2 pi fct. So if it is USB, it should be minus, right? Right. Okay. If it is USB, it should be minus. So S USB of t, I will write here. It is equal to, right, m of t. M of t. Right. It's AC by 2. What is AC? AC equal to 1. What is AC here? AC is equal to 1. Right. AC is equal to 1. Or else initially I'll write the expression, then I'll substitute. Right. That would be better, I think. Right. Initially I'll write the expression, then I'll substitute. Right. Okay. Yeah. So it is. Should I change the ink color to red or green is fine? Which one do you think is better? Which one gives better visibility?
I think green is fine, sir.
Green is fine. Okay. Yeah. Okay. So yeah. So it is AC by 2. I'll write here AC by 2 m of t into cos 2 pi fct minus AC by 2 m cap of t times Oh, sorry, it should be sine, right? M cap of t sine 2 pi fct, right? Now our m of t is given by this, right? So what will be m cap of t? M cap of t will be, it is cosine, right? So m cap of t, Hilbert transform of cosine is sine. Just now we saw that, right? So m cap of t here, it will be equal to, I'll write straight away, it is sine 2 pi times 100k t. So not, it's not 100k, it is 100 only, right? Sine 2 pi times 100 t, right, plus sine 2 pi times 200 t plus sine 2 pi times 400 t. This is m cap of t. Now what I want you to do is, I want you to substitute it here, right? You substitute the value of m of t. So I'll write it here. S USB of t, S USB of t is equal to, AC by 2 will be actually what? 1 by 2, and m of t will be this, cos 2 pi times 100 t plus cos 2 pi times 200 t plus cos 2 pi times 400 t, right? This is m of t into cos 2 pi times, this is 100k, 100 kilo ohm, kilo hertz, 100k t, right? Then the second term will be AC by 2 m cap of t. So plus AC by 2 is 1 by 2, m cap of t is sine 2 pi times 100 t plus sine 2 pi times 200 t plus, it should be minus. I'm sorry. Thank you for pointing it out. Right. It has to be minus. It's not plus. It has to be minus. Thank you. Right. Minus. Right. Plus sine 2 pi times 400 t. Right. Everything into sine 2 pi times 100k times t. Right. So this is what we have. Now I want you people to expand this. Right. How to expand? Right. Simply cos 2 pi into 100 t times cos 2 pi times 100k t plus cos 2 pi 200 t times cos 2 pi 100k t. So I want you people to expand. Right. I want you people, I will give almost 5 minutes. Right. So I want you people to expand it, right? Everyone should do it, right? I may ask anyone to what present, take a click and show your screen, right? You should be able to do. I'll give, say, some to expand this, and after expanding, you will get say cos A, cos B terms. You may get cos A, cos B sort of terms. Product of two cosines, right? So we already know what is that. It is half cos A minus B. What is this? Cos A minus B, plus or minus? Plus cos A plus B, right? So half cos A cos B term will be there. That will be half cos A minus B cos A plus B, and there will be sin A. Again, here we will, if we expand the second term, we will have sin A sin B terms, right? We will have sin A, sin B terms, right? You will have sin A, sin B terms, right? So that, what is sin A into sin B? It will be, can anyone tell me, half of cos A minus B, cos of A minus B, minus or plus, it is minus, right, cos of a plus b, right. So you have to expand it, and you have to expand it, and you have to expand it and then apply this result, right. And please do let me know what you are getting, right. You have to expand it, right. So I'll give you 5 minutes, everyone, right. The problem is if you just write down this on sheet and keep on staring it, nothing will work out. You should take your pen and paper and start writing. You just write, it's nothing is there. Maybe I can just show it, right. Right, so you just expand it and apply these results. Right, expand it and apply these results. Please do it fast. So now it is 9:32. I'll give time till say 9:40. I can give time till 9:40. Not a problem. Right, please expand this. Yeah, last 1 minute. So you should have terms with, like now, please listen, you should have terms with 100K plus 100 hertz and 100K minus 100 hertz. Then you should have 100K plus 200 and 100K minus 200, and similarly 100K plus 400 and 100K minus 400. You will have all these terms, right? So this, whatever this 100K is FC, you can take 100 hertz as F1 and 200 hertz as F2, 400 hertz as F3. So you will have FC plus F1 and FC minus F1 terms. We have already seen that, right? So now upper sidebands will be actually what? FC plus F1 terms. Right, upper sidebands will be FC plus F1 terms, that is 100K plus 100 hertz, 100K plus 200 hertz, 100K plus 400 hertz. So if this is FC, I have drawn the spectrum here, right? So there will be 100 plus 100 hertz, 100K plus 200 hertz, 100K plus 400 hertz. So these things will be upper sideband, and 100 minus 100 hertz, 100K minus 100, 100K minus 200 and 100K minus 400 will be lower sideband. So it will be there on both sides. In negative side also it will be there if you plot spectrum. But for you to appreciate the which are the terms available, right? I'll show only positive side, right? So we'll have this. So once if you pass through a filter which will allow only upper sideband. So we have seen what should be such a filter, right? So a filter which will allow only upper sideband and will eliminate the lower sideband. So if you pass it through a filter like this part will be removed. So whatever, right? So you should get, so when you expand it and apply cos A, cos B and sin A, sin B results, right? You will get cosines with, right, 100K. All will be cosines. Why? Because even if it is sin A, sin B or cos A, cos B, we have only cosines, right? So you will get cosines with FC plus or minus F1, FC plus or minus F2, FC plus or minus F3. In that, after we get that, what are we doing? If you see the block diagram, once we get this, we are passing it through a filter which will allow only upper sideband, right? So SUSB will get, after we pass, whatever you go through a filter, so it will have only actually what? These components, 100.1 kilohertz, 100.2 kilohertz and 100.4 kilohertz. Or you can write FC plus F1, FC plus F2 and FC plus F3. So this is the SUSB of T. It is the SSB signal, right? This is SUSB of T. Now what you should do is you are going to what? Again we'll go here. Right, again we'll go to our system model. Now you are using a coherent detector. So this is our coherent detector. This part is our coherent detector, right? So this coherent detector has a local oscillator, right? This is our coherent detector. This is our coherent detector, right? It has a local oscillator. Actually the frequency and phase of the local oscillator should be exactly same as this, but we do have a small offset here, right? We do have a small offset here. We do have a small offset of say 0.2 kilohertz here. There is a delta F of 0.2 kilohertz here, 0.2 kilohertz, right? So in coherent detector, what happens now? What you have to do is you have to multiply this SUSB of T with this cos 2 pi FC plus delta F of T, right? Cos 2 pi FC plus delta F of T, right? So what you can do is for this part, you can initially keep instead of 100 plus 0.2, 100 plus 0.3, and you can keep FC plus F1. Sorry. I'm sorry, actually my mouse is giving me some trouble. Right, today, right. Oh. Let me just try and fix it, please. Yeah, so, okay, I think this would be, okay. Yeah, let's, Yeah. So what I can do is, okay, something went somewhere. This part, okay, it was here. Okay, no problem. Fine. So you can write it like this. Then what you should do is the coherent detector, first part of coherent detector output, you should multiply it with cos 2 pi fc plus delta ft. Maybe you can call this output as, say, you can call it v of t. Right, you can call it v of t. This v of t will be equal to s usb of t plus this into this, right, into this. Okay, one second, I'll write here. So v of t, that is actually what product modulator output of the coherent detector. It will be s usb of t into cos 2 pi, right, fc plus delta f into t. You can write it like this only, then it will be easy for you to what understand. So then what is this s usb of t? S usb of t I have just written here, ac by 2 cos 2 pi times fc plus f1 into t, right, plus cos 2 pi times fc plus f2 into t plus cos 2 pi times fc plus f3 into t, right, this much into, we have this cos 2 pi fc plus delta f, right, into t. So again, if you expand it, you will get cos a cos b terms. So this will be fc plus delta. You can take this as actually what anyone, right? So this is cos a, this is a, and this is b. So you'll get cos a cos b terms. So you have to just multiply it. So what is cos a cos b? Again, we have seen it here. Cos a cos b is half of cos of a minus b plus cos of a plus b, right? You expand it like that, right? I'm telling you, you expand it like that, right? So are you getting this? If you have any doubt till here, please feel free to ask, right? I would take if some doubt is there till now. Any doubt is there till now? Only thing is, it's right, some labor sensitive. We have to do it, right? You can't simply sit and watch. You have to just write and expand, right? You don't have to even use your brain, right? Simply you have to what? Only it's the use of pen and paper, right? So any doubt is there so far? So this is going to be your assignment. We won't give you much time, right? Is it clear? Like, yeah, you can type it in chat window, right? Is it okay? Is it clear? So far, the only thing is you have to write down, right? Only thing is you have to write down. So you should know what is the system model, and you should write down and expand. And it's just applying actually what cos A cos B, right? Expression in. So I'm not getting any message. Am I audible first of all?
Yes, sir. I have sent a message, but it's not. I think you're not receiving it. It's like showing me that it's sent now.
Yeah. Okay, now I received. So there is some problem altogether, right? So maybe today is Saturday, right? I don't know. There is some serious issue. We should, right? Okay. So maybe if a message is not received, you can just unmute and tell, right? Not a problem, right? So okay. So just do this. Just expand this, right? Just expand this, right? You should do that, right? Once you expand that, what you will get is, again, you will get sum and different terms. You get fc plus f1 plus fc plus delta f and fc plus f1 minus fc plus delta f or whatever, right? Or you can take this as a, right? You can take this as a and this as b, right? So you will get again sum and differences, right? Again you will get sum and differences. Then, right, you should write what is this v of t, right? You should write what is that v of t. It will have sum and different terms. Then after that, right, what we are doing is we are passing it through a low pass filter, right, which is tuned to the message frequency, right? So finally we'll get some spectrum, right? So it will have actually what, say 100 hertz, it will have 200 hertz, it will have 400 hertz, right? Also FC term will be there too, right? FC plus something will be there, 2FC plus something will be there. In this, if you expand this, right, you will have these terms. So, but finally what you will be doing is you will be passing it through a filter, right, which will allow only what, up to say less than FC, right, less than FC, right, or only message components, right, message components, say, right. So you have to see whichever frequencies are falling within this, right, whichever frequencies are falling within this 400 hertz, right. So whichever frequencies are falling within this 400 hertz, that will be the output of the coherent detector. So now please try and find out this V of t. So before that, maybe if I may ask someone who has done this, if someone can tell me what is SLSB of t, final expression what you got. Maybe I should stop sharing the screen and I'll ask who, any volunteer who has done this. Now let me ask you a thing seriously, right? So maybe I should call some name and ask, right? So if I ask Satvik, can you please unmute? Yes, Satvik is not there. Sharanya. Sharanya is also not there, or you are not able to unmute. Right.
Yes, sir. Yes, sir. I'm where?
Yeah. Okay. I think you have some background noise. That's why. Right. It's okay. Yeah. Yeah. Not a problem. So, what is your opinion about this problem? It's you don't have to what. It's not a difficult problem and all. It's a bit lengthy. Right. What I'll do is, right, today as I have to finish this session at least by 9:55. Right. I'll just right. I'm just giving you this idea. So what you should do is you should write the expression for V of t. In the expression for V of t, we will have so many components, so many frequency components. In that, whichever frequencies are within this 400 hertz. Why 400 hertz? Why 400 hertz? Because this is the maximum frequency content of our message signal, right? So if I'm using a low pass filter, right, for a coherent detector, it should allow only the message part, maximum frequency content of the message, right? Normally, right, if it is perfectly synchronized, I am supposed to get only 100, 200 and 400 hertz, right? But as we have a delta F here, right, right, that will produce other frequency components as well, right? That is the main idea. As we have a delta F here, delta F is nothing but what? The local oscillator is not producing exactly FC, it is FC plus delta F, right? So this delta F will produce some unwanted components, right? That also will fall within this low pass band, right? So you should find out which are the frequency components. So right, so what I'll do is this sold out example I'll post in Canvas, right? So now if you have any doubt in this, any lack of clarity in concept in this, please feel free to ask question. I don't think it's right that difficult. So if you have any doubt, you can either type it in chat window or you can unmute and ask. Right, how, like, I can't accept, right, the class of 61 students, right, with no doubt. Right, either you are not listening to the class, you are like doing some other business, right? So, okay, Savan is again typing option 3. So maybe Savan, thank you. Right, but you can't, right, keep everything for later. Anyhow, you are attending this class, at least for attendance sake, right? Maybe rather than actually what gaining knowledge, why one should, like, rather than actually what attendance, why one should attend such a boring class, right? At least for attendance sake, you are attending class. So try to learn something. So now at least it's fine, right? You can say I'll learn later, right? But when you move on to higher semesters, you will have more and more works, right? Especially in 7th sem and 8th sem, you will have to do your project, you will have your internship, you will have your this seminar evaluation, right? For each and everything, you have to prepare report. And apart from that, BTU has kept some subjects as well in your final year. So if you have to manage, right? So whatever time you are spending in class, try to learn something. Maybe you are of the like say. You have a habit of studying everything on your own a day before exam, but it may not work every time, right? So at least, right, for attendance sake, you are attending class, but try to learn something, right? Just imagine, like, just remember what happened when you were in schools or even in PUC, right? You used to learn something in class, right? Now your mindset is different, right? Now you are grown up, right? Is it the case you don't want to learn anything in class? And at the end, right? Okay, like once, okay, let the college reopen, right? Then I'll be able to see everyone's face. I will be able to what interact with everyone. That time, maybe at least that you can ask them. Doubt. I'm not getting seriously. What you don't have any doubt, but you are not. Is it because you are keeping it aside? Maybe later I'll study. I find maybe something is missing, right? So I'll keep it aside. I'll study it later, and that later will actually what indefinitely right prolong, and that later will happen only a day before your exam. Is it the case? That also, right? So okay, I'll the sold out example I'll share in Canvas. Right, the sold out example I'll share in Canvas. So please do that. And the second part you have to do it as an assignment. For that I'll create an assignment in Canvas. You have to submit it. This will be your actually what most common and graded assignment. Right. The other assignments will be there. That will be considered for moderation and all those things, whichever I have given. Right. So this is the first assignment, which is common for both A and B section. Right. Okay. If any doubt is there, you can either like message me or mail me, whatever. If you want, you can call. Not a problem. I'll be ready to clear your doubt. Right. And yeah, anything else? So I think that's pretty much it. Now I should leave. Right. I have some other commitment as well. Right. So maybe thank you so much for joining the session. Right. Before you leave, please wait. Right. Before you leave, right, I'll just, right, yeah, so thank you. If you don't have any doubt, you can just leave, right, thank you. Yeah,
Thank you, sir.
okay.
Welcome to the webinar. Please stand by.